Okay, you should have stream.
Okay.
Something should pop up on
Yep.
YouTube.
It just popped up.
I don't know.
I don't know. Waiting. Excellent connection. Okay, it's just got booting up. There we go. Play it in public.
And that's our composite.
Okay, so then
Then M on the bottom right, you got that's the logo on the top. Yeah, so we have full frame and then it's
got it.
I'm not in frame right now. But,
Right. Okay.
and then I got for an SF logo in there.
Nice.
I throw a plug down there just because
And then what do I need to do? Like say live. Oh, it's already going.
it
Says in stream. So presumably it's already happening.
oh yeah, it does say live, doesn't it?
So I should say share video link. All right, cool. Let me edit this into the
And here what I'll do is I'll just mute. Hi everybody watching on the stream.
oh
We'll trim that later.
yeah, I can edit it out or whatever. Make sure this we're good.
Check, check, 1, 2. Hey everybody.
Okay. All right. Welcome, everyone. We are live here. Welcome to San Francisco Java User Group. My name is Peter Humphrey. I'm your friendly neighborhood organizer. Um, we will hear from Michael in just a moment. We're trying to do in-person events a little more often. We've been doing virtual events all the way out through COVID. If you haven't gotten a piece of pizza, now's a good time. Grab one. Um, I work for MariaDB. Anyone here heard of MySQL? Okay, that was a trick question. If you hadn't heard of MySQL, I was going to escort you out. Just kidding. Yeah. And then Logic 2020 is a consulting firm in Seattle that is kind enough to sponsor the Zoom. This is a volunteer effort, so there's a lot of sponsors involved. Microsoft is obviously donating the meeting space, which is great. And then we have folks on the organizer committee as well. There's a team of like 5 co-organizers. Some of them work for Gradle. Another one works for Event Store. And we even have Chris Richardson, who is like the godfather of microservices, helping us. Today's pizza is sponsored by a company called Stitch. They have some hats and stickers there if you feel like grabbing a little swag. And if you haven't heard of Stitch, you might have seen some of their campaign in San Francisco. I think they're startup. They're doing kind of auth N, auth Z, and they have a Java SDK, which I believe is MIT licensed, it's open source. And so yeah, they are kind enough to sponsor the pizza tonight, and the swag. So again, thank you to Stitch, and I'm curious to find out what they do because I had never heard of them before 24 hours ago when they stepped up and said, "Hey, let's buy the pizza." So that's pretty cool. They are hiring, so if you're looking for a gig, that's a good thing to take a picture of with your phone. And that's how to get started with their Java SDK. But yeah, I guess oh, sorry. I guess this is like Auth0, Okta, maybe something like that. I haven't had a chance to look at it too carefully, but I guess they are doing yeah, they're doing a Java SDK, and I guess they're like an Auth0 thing. So okay, I think with that, that's the beginning of your slides, right?
Yep.
So let me just say, we've got a lot of upcoming events. Um, so check the SF Java meetup page. We have events all the way going into almost like August right now. So there's a bunch of good stuff lined up. We've got Marcus Hellberg from Vaadin, which is a front-end Java kind of GUI builder. We just had Jennifer Reef from Neo4j, who's awesome presenter. She was really good, along with Brian Benz from Microsoft, talking about generative AI. And we've got a number of other good presentations coming this summer. So please take a look. I found out something that made me about the meetup.com platform that made me physically ill. If you don't come to the meetup page once a month-ish, it will silently remove you from organizer communications. Sorry. And so if you want to hear about events, you have to come to the meetup page every once in a while. Not my policy. I know, totally. It's like when I found that out, I was like, oh, you gotta be kidding me. I tried raising a stink on their Discord. Nobody like paid attention. I was like, is anyone aware of this? Anyway, because like COVID basically, right? Nobody went to meetups for 2 years. So that means your lists are zeroed out, right? So it's like whatever. Um, Anyway, tonight, my good friend and longtime industry conference circuit presenter, Michael, who has some magician skills as well as some technology skills, started off as a developer. It was always both. Always both. Excuse me, my mistake. Yeah, when I was working at VMware and doing organizing the Spring One conference, we had him book a number of times. Great speaker. So he's going to talk to you tonight about Agile architecture. We are recording this as soon as I sit down and hit the record button, and then we will send you a link to the Zoom record, to the YouTube channel for the recording if you want to share it with your colleagues or other people that are interested in Agile concepts. Okay, any questions before we get started? And also, we'll save a few minutes at the end for questions. If you have a burner, this is informal. Just say, raise your hand, be like, hey, Michael, and we'll hand you a microphone. I'll repeat the question for the people online, and yeah, otherwise just save your question for the end. But if you got a burner, just jump in. Yeah. I think that about covers it. Thank you for coming. Thank you for coming. And next time, bring a friend because we're trying to get in-person events started again because now that COVID is lifted and um, it's just difficult to work with these corporate folks sometimes with all the security and all that. So, okay, great. Thank you, Michael. Take it away. You gonna hit the record?
Yes. And we will be live. Second.
Live. First and foremost, I'm a big round of applause for this man putting this event together. He has been busier than whatever the saying is that is probably not appropriate for the recording, so I'm going to leave it there. He's busier than that, whatever that saying is. As you said, my name is Michael Carducci. I do a lot of things. I'm an independent hands-on software architect. I am also a professional magician. I'm both. I didn't realize that could be, I'm not one turn the other or the other way around. I've always done both. I started doing magic the same year I taught myself to program in the 1980s and continued. Tech has taken me all over the world. Magic has taken me all over the world, and putting them together. It's been interesting because doing those two things, living at the intersection of magic and technology, has been interesting. It's been illuminating, and it gives me some unique perspectives on a lot of things. Because think about it, he's a magician. Well, I was an engineer, a software engineer, technology, whatever. Right? We try to go up to that line of what can be done, what is possible. And then that's where we stop. And as a magician, that's where we stop. It's not possible. Don't even bother with it. It doesn't matter. So I found this out at some point that it gave me a really unique perspective on a lot of things. It gave me a bunch of ancillary skills that help whether I'm speaking or trying to present an idea to the business or get a team on board. That it's all these, they all cross pollinate. I'm a big believer in what David Epstein in his book Range calls range. And I guess what our Buckminster Fuller calls synergistics. I don't know. I think it's the unison or the chorus of all of our experiences and all of our knowledge and all of our perspectives that make every single one of us just gives us that unique insight and perspective to solving problems. I also have a book coming out later this year, Mastering Software Architecture. Some of the ideas and models and things like that are going to be expanded in there. I think it comes out later this year. In fact, I had the publisher chasing me about something earlier today. You mentioned I'm a magician, and I can't, in addition to everything else I do, I can't start without doing something. I mean, this is for me. This is for me. So reading this year, July. Well, no, it was last year now. It's 2024. Who am I kidding? Time flies. It's my birthday. My wife knows I like these types of things. She bought me a puzzle. And I like this puzzle. It's interesting because there's more than one way to put it together, but the definition of whether or not it is done or not is whether it fits in the box because it fits pretty tightly in there. But so there's different ways you can put it together, but then it fits or it doesn't. And a lot of this stuff that I'm going to talk about came from this idea, broadly speaking, of architectural fit. And, it's not just the technology side, it's not just aligning technology strategy with business strategy. Like your architecture has to fit the organization, the teams, the environment that you're in. And that fit, just like a suit or anything else, it's going to change. So imagine this, if you will, as let's see if I can get into frame, as a metaphor, because architecture is really the sum of all the decisions we make on a project, whether it's, what patterns we're going to follow, what technologies we're going to use, whatever, right? But you put the pieces together in the right way, and you get some kind of fit, if I can actually remember how to solve this puzzle. Yeah, you get fit at least for a time. If you have the right pieces put together the right way.
Now, Grady Booch once famously stated that architecture is, quote, the stuff that's hard to change. But anybody's ever done this, you realize you've got your exemplar, you've got your architecture. It fits, it's perfect, it's beautiful, and the business says, an idea, or the market changes, or you get acquired, or whatever. And one of two things are going to happen. Either this whole thing is going to fall apart, or depending on skill, experience, team, everything, you might find a way miraculously to make this stuff with change still fit. And I know you're thinking, hey, we've all seen the candy bar that we've sliced, and somehow we found that extra square of chocolate. We got the infinite chocolate hack. And maybe this is just some trick of geometry, although I don't know how we can figure out how to get whatever that is, 2 square centimeters into that already full box. This doesn't matter, because this isn't something that we're just going to have to do once. It's one of those things that's going to happen again and again and again and again. And it's not always those little small changes. Sometimes it's a much bigger change. But what I want to talk about today is give you the secrets to not only be able to solve this puzzle of architecture faster, more deterministically, and more reliably, but that no matter what changes come your way, no matter how the organization, the project, the teams, the needs evolve, you will always have an architecture that is a perfect fit. Thank you. It's remain. It's also completely impossible. And yet, and that's my point. It's perspective, perception, all of those things. But I've titled this talk Agile Architecture, and I already hate myself for doing this. So I would take a moment, because we really need to talk about Agile and what that means and what it has become, because you go anywhere. Agile is everywhere. It has been everywhere for 15, maybe 20 years. Every job posting, hey, we're Agile. A colleague of mine on the No Fluff Just Stuff tour is very fond of saying, whenever he brings on to a client engagement, the first thing they say to him is they say, oh, by the way, we're Agile. And he says, great. I am so glad you got that off your chest. Now why don't you tell me what you really do? Because that doesn't mean anything. And all of these words that we bandy about, we call Agile, it does not mean what we think it means. And it just got out of hand. It got insane. I remember the first time I walked into an organization and they had the giant poster of the SAFE framework. Now, I couldn't find the complete poster. They had the entire thing in one infographic. This is like a little piece of it. But the first time I saw this, I thought it was a joke. I thought it was one of those parody posters. I remember 20 years ago, maybe, I don't know, they had those inspiring posters. It's like some picture of a bald eagle soaring, and it's like vision, some, some word. Uh, I don't know. These motivational posters, like teamwork, and it's everybody, rowing something. I worked at a company all those years ago that had those posters. The new manager came in, put those posters everywhere because like that was going to motivate us or something. And one day I came in very early and I swapped them all. I found a company online that would make parody posters. And it'd be the same image, but instead of saying like the eagle, it was like vision or courage or whatever. It said I forget what the word was, but it was something like eagles may soar, but weasels don't get sucked into the air intake of jet engines. Burnout, yes, yes. And it was the thing was I had that poster there for those posters up for about a year and a half before he finally noticed. And then one day he stops and said, you just noticed, okay. I was a joke. The movie Office Space, like there's a scene when Peter first meets the Bobs, and in the back of this room, they had this flowchart planning to plan. because it was a parody of the industry. And they had that in the background, and that was what I thought they were parodying. And every single organization, every single consultant, every single certification body, whatever, they talk about Agile, and it drives me nuts. Sometimes I'll talk about Agile with fondness, and people will look at me and they say, I hate Agile. So, well, what do you hate about it? And they say this, well, that's not Agile. That's not Agile. You're doing that. You don't have to do that. Why don't you bring that up in the retro? Oh, you're not doing retros. You're not doing. Okay. So basically, the organization is doing just the enterprise. It's called a spade a spade. The enterprise is doing just enough to be buzzword compliant. We just want to check the box. Check. Are we agile? Check. Are we doing DevOps? Not yet. Rename the operation team DevOps. All right, we're doing DevOps. Check. We want to be buzzword compliant. This stuff, it's the insane thing. The Agile Manifesto came out in 2001, and when they published this. So there were a lot of folks in this room who weren't even like in industry yet when this happened, and all they have ever known is all of the garbage and nonsense that has been marketed as capital A Agile. And I'm going to say a couple of things. First of all, the Agile Manifesto was a product of its era. So I started my career not too many years before this came out. And they were right. The process that we were following, the approach we were taking to software development was broken. And we thought if we just threw people at it or threw more process at it, somehow we would solve these problems, but that never happened. And it is a little bit of a product of its own because it talks about using software over comprehensive documentation. And a lot of people are like, oh, so we don't have to do documentation. Awesome, because I hate documentation. That's not, it's really, back in those days, you would bring in a company to build a piece of software for you because we didn't have SaaS, all the things yet. And a lot of what you knew, you had to pay somebody for because that's before every single little nano niche has been filled by 10 vendors already. We had to build stuff. And so they'd say, yeah, we want a thing that does this. So, okay. So we're going to give you a book. Here's what we're going to build. You look at it, you sign off on it, and then we're going to build it. And we really wanted to do that because people want to know how much it's going to cost and when they're going to get it. And unfortunately, in the process, they what they really wanted was something else, but we're committed, right? And so rather than saying, hey, we're going to document this whole thing, we're going to treat this as a hypothesis and we're going to learn as we go. So this idea, it's like, where it's like customer collaboration or the contract negotiation. It's not no documentation. It's learning and evolving as we go. And somebody posted this some time ago, apparently, on Mastodon, where I tend to hang out more, but I don't really hang out on any of the social medias anymore. I don't know, they broke me. Once you look further, and say that software development is deliver what the customer wants and embrace the reality of software development as helping them figure that out, it gets a lot easier. And so the worst thing that ever the worst misunderstanding I think that ever came out of Agile was Agile's about no design. We're just going to make it up as we go. We have a hypothesis, right? All software starts as a hypothesis. This is what the customer wants. Then I put in front of the customer. I don't know whether I'm right or wrong. So how do we get that feedback faster, cheaper, and sooner, so I can act on that new information? And how do I build software in such a way that when we learn a new piece of information, we can act on that rather than say, well, shoot, we need to start all over again.
Is it okay to, as we're listening to you, to transpose the word customer with user if we're working on open source projects?
Sure. That's just what I got into because some number of years ago, you realize that there's only 2 industries in the world that refer to their customers as users. We're the other one. But yeah. Even on limited contributions in the open source world, I still kind of have this customer mindset that I'm trying to build software to make somebody's life better in some way, deliver some value in some way. So I think from that perspective, each one's user doesn't. And in fact, notably, the customer and the user are not always interchangeable.
That's true.
That's the other problem that we get into because, and this is, it's one of those problems that manifests everywhere. It manifests in software architecture too, that the customer of, say, the company standard project management tool, right? They don't even use it. They don't use it. They don't even know what they need from it. They just know that we need to standardize because we're using, Trello over there, we're using Rally over here, we're using Jira over there, we're using whatever, right? Fogbugs, I don't know. Azure DevOps. What else? There's a bunch. And the company is like, oh, we need to standardize. So we're just going to go for Jira because it has the most check marks in the column, right? They don't know, but most check marks, it must be the best. And that's a formal anti-pattern, I think, in life, but also in software architecture. It's the out of context whatever, out of context trap, the out of context anti-pattern that we're evaluating these things with zero context. But in this case, the customer, we're the users, and that's just how the chips fell in our career. Now we're using Jira every day. Create another Jira ticket. Why not? All software starts as a hypothesis. Architecture starts as well. I think one of the biggest problems we have right now with an approach to architecture is we commit to that hypothesis right away, or we throw up our hands and say, well, we'll just rewrite it in 2 years and just have at it, free for all. Okay, everything's falling apart. The wheels are falling off the bus. So we're going to do this big 2-year strangular fig rewrite nonsense. But I think it's possible. I believe it's possible to take a similar approach, start with a hypothesis of what the software, what the architecture should be, and evaluate and evolve it as we go. But the way that we're doing architecture right now, that becomes enormously hard. One, we don't have a lot of feedback loops, but we also, because that's the characteristic of Agile in software delivery, right? Is all these feedback loops, whether it's putting the MVP in front of the customer, or maybe a static analysis tool in your pipeline, or doing TDD, it's saying, and you find out, oh, that's broken or fixed, right there before you even run the application, or the integration test you have, or any of the shift left stuff, configuration management, all of that. We have all of these feedback loops in software, but what are the feedback loops in architecture? They're out there. We can look at observability metrics. We can look at performance metrics. We can look at some of these metrics, but it's when we find out that our architecture is not delivering on these metrics, it can be really difficult to change at times. And it's difficult to change over time. What we were seeing in the early 2000s was a seismic shift in how we build and deliver software. We're not just building internal applications, little enterprise applications that run in a closet somewhere and serve the building or 3 locations, or even the company, all the locations across the country or the world for a company. When you're online, the entire world is potentially your user. And not only that, the entire world now is potentially your competitor. So if you can't embrace this idea of long-term agility, being able to adapt to change over time in the software that you're building, you're going to be disrupted because somebody's going to be coming in from a green field and they're going to eat your lunch. So the problem is these individuals wrote the Agile manifesto and they put that in the web. They called it a manifesto, and because we didn't have enough of those already, and then we got so many more, but it was maddeningly vague. Like, okay, so what am I supposed to do here with this? It's a nice set of platitudes. There's 12 principles. That still doesn't tell me what to do. If only somebody would tell me what to do, and then all of the consultants and all the marketers and all the consultant and all the training companies and whatever, they came in and they were selling us, Scrum or Safe or whatever's out there. I don't even know anymore. The thing was, it said interactions and people over processes and tools. And the enterprise world was like, but we like processes and tools. Somebody was there to show up and say, we'll still use some processes and tools. And we bought them. And yes,
Well, do you remember extreme programming?
I do remember extreme programming.
Extreme programming was created by Kent Beck.
Kent,
A book, Extreme Programming Explained in 1995, which explained
Oh, yeah, here we go.
some the question really the comic was that's the living relationship program, which was a book written in 1999 by Kent Beck. And it's a lot of it came into
Yeah, Kent was an interesting individual because he was, and I think this is true generally in the software industry. It's like most of us are just trying to keep up. And, for however the stars align, he's sitting there thinking, how can we make this better? How can we make this better? And so Kent Beck, I think on a flight, wrote the first J unit and it showed it to Mark Fowler. And they actually used TDD to develop his TDD tool and started building these methodologies and trying all these things. But because one of the key hallmarks of XP, he does hate the name. He regrets that.
well, Windows XP came out, so they had to change it.
Well, that's that too. By the way, since we're at Microsoft, my favorite fun fact about why we went from Windows 8 to Windows 10 is, does anybody know why we skipped a number?
Wasn't Windows ME in the middle?
Well, Windows ME came after 90 or 98. It was like Windows 95, 98, ME, XP, and then we got Windows 7. I used to be with it, but so yeah, XP, Windows 7, Windows 8, Windows 10. What happened to Windows 9? They found out in early beta testing that there are millions of lines of code out there that are doing string comparison to saying if version like 9 wildcard 95, 98, then it's going to use all these legacy APIs. Otherwise, that's genuinely what happened. And it was easier to be like, "Yeah, we're going to skip a number rather than try to, I mean, that would be a Y2K level remediation. But yeah, no, but Pink really was doing great stuff. And I regret that I never had the opportunity to really truly do XP, right? Where the customer is in the room all the time. And you have those conversations. And anytime you can ask a question, we're the customer's representative, I guess what we call a PO, but one that was much more aware of the problems we're trying to solve, the business domain, things like that, rather than the person who's just the one sitting in your meetings and accepting stories on arbitrary and shifting criteria. But a lot of cool stuff in there, and I know a lot of people in that world. I've only met Kent Beck once. I don't think he would remember me, but there's cool stuff kind of happening in that space. But anyway, we installed Agile. We paid lip service to the actual work. It's not as bad as it was in the 90s, but it's not much better.
Well, wait.
Again, I mean, this is well, okay, let's bring this back to architecture. Can we do this? Can we what are we doing? Can we take a similar, more flexible, adaptable, evolvable approach, make evidence-based decisions, and design an architecture that is, as one of the 12 principles says, what is it, just enough, just in time? Is that one of the principles, or is that something somebody made up after the fact? I'm drawing the blank.
That sounds like he's on a mission statement.
Right? I have no idea, but I like that idea. Just enough, just in time. Maybe we can figure out. We have this hypothesis of what this needs to be. It needs to be our super scalable, super elastic, linear scalability, super fast, microsecond response time, like this beautiful, badass architecture. But that's my hypothesis. All of that, sure, but it's going to be expensive and complex, and it's going to put a lot of overhead on the people who actually have to deliver the software at the end of the day. Can we validate that hypothesis as we go, and instead stay in line with where we are, where we need to be, and I guess take a little more agile approach. But it's to define architecture. There's a lot of definitions out there. I like this one. Basically, architecture is the essence of the software. It's everything it can do beyond providing the defined features and functions, right? There's a million ways, there's a near infinite number of ways to deliver a piece of software that has a set of features, right? I could build as microservices, I could build as a buzzword if I want to, I can build as a monolith, I can build it as a microkernel architecture, I can, whatever, right? And I did necessary things with one of these agile folks and in that kind of world, deep in that world, probably, plays bridge with Kent Beck, I don't know, or Canasta. He seems like a Canasta guy. But I have no idea. But we did an exercise as a group. And as a group, we were challenged to write one line of code. And we came up with something. He wrote it down. And he says, okay, how else could we express this? After a while, somebody said, well, we could do it this way. We could do it that way. We could do it this other way. We could X, Y, Z. And we did this for, I think, about 20 minutes. And by the end of the 20 minutes, like I thought this would run out of gas in 2. But at the end of 20 minutes, we just kept going faster and faster and faster and faster. And we kept finding more ways to express that single line of code. And it left me convinced that there is a near infinite number of ways to write code that will deliver a set of features. And but what else does the system do in terms of the architectural characteristics? Is it scalable? Is it performant? Is it adaptable? Is it testable? Is it elastic? Is it maintainable? Is it understandable? Is it, there's all of these other non-functional aspects. Non-functional, by the way, I try not to say that. I like the word capabilities because I found out years ago that if you use the term non-functional requirements to the business, they will shut off. They're like, what? Non-functional? No. We care. It needs to. There needs to be a button right here, and when you click it, it puts the food into the bar. That's what we need. That's the function. That's what it is. There's no non-function. We need to invest in functions.
Non-functional requirements or requirements which, if not make yourself a non-functional.
Yes. No. Okay. I'm stealing that.
Please do.
No credit. I think that was a BSD 0 clause. I think I saw.
I think you might.
All right. Now this is a Creative Commons. I don't know. Whatever. Right? Use it. Attribution would be nice, but nobody's going to chase you down. But the thing is, the features, Agile thinks about the features changing over time. But the necessary capabilities do as well. And the thing is, we think about agility as a product of the design. So Martin Fowler, one of the signatories of the Agile Manifesto, wrote a blog post in 2007 called the Design Stamina Hypothesis. And he talks right here that there is this point where no design is better, objectively. No design is better. It's the brown line. I assume brown because that's what color a big ball of mud is. But there's a point where the design kind of starts to accelerate and the no design starts to taper off and they cross, they converge. And he calls that the design payoff line. Sometimes it occurs in weeks, not months, not always. And sometimes we never get to the design payoff line. And that's not a bad thing because if we built something, got it to market fast, and found out that it is not at all what the customer wants, the user wants, whoever the market wants, then we get thrown away. No harm, no foul. In fact, Joe Yoder, who coined the term, Joe Yoder and Brian Foote, or Footy, I've only ever read it. Foot. But there's an E on the end. It throws me off. But actually like languages that are explicit about how the vowels sound, the diacritical marks but whatever. English, we just have English and software makes sense, right? Whatever. We make it up as we go. Duck typing, yeah. He says the big ball of mud is not necessarily an anti-pattern. Like everybody read on a paper and said, oh, it must be an anti-pattern. It just only makes sense below that design payoff line. The idea here, what Martin Fowler is basically stating is that the good design is going to lead to sustainable change. It's going to lead to that evolution. Makes sense, right? Because we have our choices. We have no design. Joe Yoder's Brian Foot's big ball of mud. And then we have good design. What is that, right? It's this idea of good design. It's elusive, it's subjective, and it's mercurial. And it's going to change. So we look at architecture right now. We look at all these patterns. Great. Which one of these is good design? There's no objective answer. To quote Mark Richards, it depends. And so I've been kind of in the architecture space now for about 15 years. That's really been my focus. Like that's really been the roles and the titles and the responsibilities. I've touched on this stuff from time to time because I've always worked on a lot of smaller, or typically worked on a lot of smaller teams. But the last 15 years, I've been in architecture focused roles. And in that time, I've seen a lot of projects fail, whether it's as a consultant, a practitioner, an employee, whatever, as a speaker, talking to people, all of these things, disproportionately with microservices. I would define failure because certainly epic fail is when the entire project gets canceled, everybody gets laid off. Like I've seen that happen. It's bad. Most of the time, there is a fundamental failure, but we limp along, and it's just far short of what it could. The system failed to live up to its potential, and I've spent probably the last 10 years thinking about this, trying to figure out why. Why does this happen so often? Why is this just the universal story? It's funny. I gave a talk some time ago about those patterns, and I included the Mark Richards and Neil Ford kind of scorecards, if you've seen these in their book, Fundamentals of Software Architecture. And someone kind of looked at this sideways and said, are those scores universally recognized? And are they, is that like official? Or is this just like your experience? And I thought it was really insightful because what it is these patterns promise to give us rarely actually materializes. You look at microservices and all these high scores in terms of elasticity and scalability and agility and all of these desirable characteristics. And by their scorecards, it's the best there is. But the reality is so rarely does that pattern deliver on that promise. Now, what it does in spectacular fashion, right? You look at Netflix, amazing. You look at Amazon, right? Not what they were doing in Prime Video because they put everything back in a monolith last year, as you may recall. Some of these large organizations where that's a real problem and they're doing microservices insanely well. And you're like, yeah, that's what. But so seldom do we actually get there. There's a lot of parallels to the problems that the folks who wrote the Agile Manifesto were trying to solve. And so what I did was I started really spending more and more of my time thinking about this and trying to kind of codify this and understand this and do a lot more deep research, not just like what's happening today, but going so far back. Because one of the things I've realized in our industry is we're still in a case where we're just mostly trying to keep up. And, keep up was doing a little bit of forward thinking stuff in the 90s. And if you think where we are today versus the 90s, we would love to keep up with the pace of the 90s versus today, where so many times they start with a slide like, today it is April 17th at 7:20 p.m. Pacific time. And they have to timestamp it with that granularity because what they're talking about may change within an hour. And we're still trying to keep up. But what happens when you've got an explosion of information and we're mostly just trying to keep up is over time, we forget what we've learned. We forget what things mean. Martin Fowler talked about that with this concept of semantic confusion. Like, he and a bunch of folks came up with Agile, and nobody means what they meant. Literally nobody in the world means what those signatories meant when they coined Agile. And it's probably even worse for Roy Fielding, who coined REST. And literally nothing in the world probably that is defined as RESTful adheres to the architecture that Fielding prescribed. No, he didn't prescribe, he described. And his whole point was not, hey, here's REST. It's, hey, here's a model for designing architectures, a better way to build architectures. For example, here's how I apply this to the work that I did with the World Wide Web. So this is the architecture of the web. It's called REST. And you can build your own. And everybody basically skipped the first 4 chapters, went straight to chapter 5 where he talks about REST. And then we all do REST, but, sort of. And then we get half implementations that become reference implementations. And it's just a game of really bad telephone. But I started going back, I started looking forward, I started thinking about these, having lots of conversations with clients, with folks in meetups like this, at conferences, everywhere. And I started putting together what has become the tailor-made software architecture model. A way to take all of the pieces that we have and put them together in a more comprehensive way, in a more holistic way. And so basically take all the fragmented models we have and unify them together. Connect, build on this body of knowledge and connect it. So the whole idea, the whole metaphor, and this is also vaguely why I'm wearing a sport coat today, because I feel like I should have a jacket that fits, is the broader underlying metaphor is this idea of architectural fit. Does it fit? And it's not just does it fit the business strategy? It's got to fit the teams that are actually going to have to deliver this architecture. And a lot of architectures don't fit the teams. It's got to fit the organization. And a lot of architectures don't fit the organization. If you want to build microservices, that is a domain partitioned architecture. And if you have not done the work as an organization to basically do the DDD work, it doesn't matter what you design. Conway told us this, 40, 50, 60 years ago, 1967, that whatever kind of system you're building, you're going to get mirror of the communication structure of the organization. And then later, when we looked at this in the context of software, yeah, it's true again and again and again. It doesn't matter what you design, you're going to ship the org chart. So unless your org chart mirrors that microservice architecture, you're not going to get there. You're not going to get these benefits. So it's going to fit the organization. It's going to fit the strategy, the goals and the strategy of the business, not just now, but it's got to be able to fit the current climate and the future climate. It's an ongoing thing. And so I like the suit metaphor because not only does a suit have to fit your body, but it has to fit your wardrobe, where you're going to be wearing it. It's got to fit your personality, like all of these things. And architecture in the same way, just like there's a lot of dimensions to fit to clothing, there's a lot of dimensions that fit to architecture. So how do we look at architecture in this broader, more holistic context? And that's really what it comes down to deliberately designed and crafted solutions with holistic fit in mind. So I'm gonna just broad strokes the model because that's what opens the door to this more evolvable and potentially more agile approach to software architecture. It starts with defining a technology strategy that is informed by the business strategy. That means we can't have an architecture conversation until we talk to the business. In 2020, I had speaking and clients and magic gigs and all of the things that I do. And then abruptly, right at the end of the first quarter of 2020, everything kind of went into a holding pattern. It was weird. Like events were kind of postponed. I don't know. You might have some news about it. You might have seen it. But in 2020, I realized, oh man, I should have been saving money. Now I got to go get a job. And I had to go find a job. And I came into the company. They brought me an S&P. I was the chief architect at S&P, and I was overseeing this kind of startup within the enterprise. And when I came in, I said, so cool, tell me about what you're building. And they sent me the architecture doc. And it's like 1999 all over again. I got the technical specification. It was because I printed it. And they have a binding machine in the office that I couldn't change to. There's nobody there. So I'll use your printer. I'll use your binding machine. I'll take home some of your batteries. I don't know, like sitting there. Expires. I mean, just for the environment. That's why I was doing. And now this is recording. Well, I don't work there anymore anyway. What are they gonna do? Fire me? I don't know. But I printed this out and I still have it. And it's a two and a half, three, I don't know, whatever that is. That big. Yay. And it's annotated and I've got little sticky notes in there, and it was super comprehensive. Like it was detailed. It was like every little detail. This is the specific implementation details of microservices, and this is how we're going to implement circuit breakers or whatever, like all of that detail. And I said, cool, what are we building? They said that. I said, okay, sure. We're building microservices, like really, you read production ready microservices. Well done. Because there's a lot of that in this Bible. What are we actually building? No, what's the and they said, oh, I don't know yet. Nobody really knows. They're still figuring it out. I'm like, this is going to go swimmingly. And then I had the audacity to say, we don't want to start with microservices yet. And they're, no, microservices are good. Everything else is good. Do you suggest a monolith? Maybe. So that was the end of that conversation. But no, it's our technology strategy has to be informed by the business strategy. So we start there. We connect everything to quantified and qualified system capabilities. We got the requirements. Let's figure this out. We need availability. How much? You can't just go to the business and say, how important is availability to you? Oh, super important. I don't know what to do with that. So give me a number. Okay? 100% of the time. You can have that if you want. There's this line in the movie Lock, Stock, and Two Smoking Barrels when he says, this guy keeps asking for stuff. He's like, gold-plated Rolls Royce, as long as you pay for it. And so you've got to like flip everything around. Okay. How would the business be impacted if we had 6 seconds of downtime a week? Would that like destroy us? What about 60 seconds? What about 10 minutes? What about an hour? What about 10 hours? Okay, you can find that line. So we got to figure out what matters in what measure and connect, or at least what our hypothesis of this is. Because they don't know either, and we can only guide them so far. And some of it we're going to learn as we go, right? Then design and architecture that will actually deterministically induce those capabilities. Not just, well, microservice is supposed to be super scalable, except the way we do it, it's not. How do we do microservices or whatever architecture in a way that the scores that Forward and Richards give us, that it's going to be like this or whatever for whatever the architectural capability key interest is? How do we actually get that? How do we actually get that deterministically and reliably? Because just, copy paste pattern isn't cutting it, right? So it introduces this idea of how we induce these capabilities. I'll talk a little more about that in a minute. Then we evaluate the architecture for organizational compatibility. Like, oh, we want to do that, except we got feature teams. So like, this is not going to work. We need to either change the organization or change the architecture. Then you've got to be able to document it, communicate it, and drive the change. That's the whole other aspect of it. It's like, okay, I've got the idea of design the architecture. How many actual like architect-y type people, regardless of what your title is, how many people kind of do that kind of thing right now? Okay. How often have you, in your career, have you said, here's the architecture, and the development teams said, no. And that was that? And then, yeah, it happens. So, how do we get better at that aspect of it and all these other things? And then we need to be able to measure, learn, adapt, and evolve and spend, it's a constant process. It's not design it. Here's the Lucid app, Lucid chart, Lucid. I don't know. What do we use today? Miro now? Yeah. There it is. There's my diagram. I almost said Visio because I don't know, Microsoft's kind of messing with my brain while I'm in here. Which I don't think used Visio in the last 10 years.
No. But I
Yeah.
remember it.
It's still around. It's still around for some reason. But the thing is, this last one is so important and it's so often missing because this idea changes over time. So this makes the first thing, good design, so much more challenging because right here, this is good design. Joe Yoda's big ball of mud. It's a good design. Here, not here. We need something else. We need a little more structure. We need some kind of structure there. And then, at some other point, there was another line where the investment of into a distributed architecture starts to pay off. And at that line, well, yeah, if we've got some kind of distributed architecture, that starts to pay off. And again, somewhere else where we do the whole reorg and we do a whole DDD thing, we all get together and some of us buy stock in 3M because we have knowledge that we're going to go out and buy a metric ton of post-it notes and their quarterly sales are going to uptick. So at that point, we do that, but that's a lot of work. It's really expensive. But there's a cutoff line where it pays off. Okay, then we're doing microservice, or then we're doing some kind of domain partitioned architecture. No, there's a microservices line. It's way the hell up there. But there's a point where it pays off. But the thing is, all of this, it makes good design so much more challenging. And so my question is, do we have to start here? So if we say our hypothesis is microservices will eventually make sense, can we test and evolve as we go, or do we have to design this all up front? Can we be more agile in our approach to architecture? Can we empirically determine what is enough? But ultimately, does it have to be big design up front, right? And all of front loading all of the effort and all of the complexity and all of the infrastructure investment and all of the upskilling of the development teams and all of it, because you need all of that. To quote Neil Ford, he's very fond of saying, you need to be this tall to ride the microservices ride. You need to be at this point, you basically need to be as tall as the microservices payoff line or very close to it. But what does this really mean? Well, we're starting here, and now we look at not just Tyler's going to give us all these cool scores, all these 5 stars in terms of agility and deployability and elasticity and evolvability and fault tolerance and scalability and testability. 5 stars across all of those. So many great things. And it can, but the current architecture models don't connect this enough to what this requires, because so much of architecture focuses on just the technical and topological aspects of the architecture. But we also have to consider the human and the organization. So every single decision that's going to get you these scores, the tailor-made model is going to say, okay, that is also going to require an investment in domain-driven design, domain-aligned teams. So you need the reorg. You actually need to do something after you spent weeks doing all of that stuff. Sophisticated development teams. We need mature development processes. We need high automation in dev. We need an organizational commitment to DevOps. We need team independence. We need good, quality, robust, mature CI/CD pipelines that the teams own, that we don't have those bottlenecks anymore. We need an environment that enables high operational automation. And when you actually do the work to get an organization to this point, to get to that line, especially if we're doing this upfront, before we're even getting payoff for this, before we're even getting benefit for this, you realize that this introduces so much pain. And it's premature. And I apologize, I don't have a better video, but I was trolling YouTube and this is what I could find. So here it is. I've been on so many software projects where I wish I could stop the ride. So what are we doing? Is why do we stand on the candy apple so we can pretend that we're tall enough, just so we can brag about our badass microservice architecture? Well, we look at these two, our old standard layered monolith and microservices. And the reality is sometimes this is fine, right? It might even be preferable on day one, but there's a point where we think that we want to be closer to that. And we know from experience and everybody else's experience and just intuition that going from here to here involves so much pain. But if you ever prematurely adopted microservices, doing that painful rewrite, uh, we don't do the painful rewrite, but the alternative of starting there involves yeah, so much pain. I already said that. So much pain. So starting there, it's like pain now or pain later. And it's like technical debt, pain now or pain later. Well, we'd rather just get it off the way, rip the band-aid off. But both of these are so much pain. And really though, whole this whole it's a false dichotomy. And it's a consequence of pattern-based architectural thinking. One of the worst things that comes out of this is this idea of hearing architecture patterns, and some grids and variations. We can build microservices and hook up Kafka, RabbitMQ, or something in there, and then it's like event-driven microservices. But ultimately, you're seeing that the myriad problems, business problems, technology problems, people problems, software problems, we can fit all of those into 9 sizes. And my idea of fit, I don't believe this is the case. In fact, I think you can't. And also, what does it even mean? What's the other problem? So, anywhere you go, just like Agile means something different everywhere you go. Microservices mean something different everywhere you go. You go to a company that's doing microservices very well. They're not doing microservices right. They're doing microservices right for them, for their domain, for their business, for their specific challenges, their specific environment, all of those things. You look at somebody else who's doing microservices very, very well, it's going to look different. And then you've got, for every one of those, you've got 100 people who are doing microservices terribly. But they're still the reference architecture for the rest of these people's career. So whether you get some idiot that says, well, this is what we did at my last job, so let's do it over here because this is what I know to do, therefore this is what I'm going to do. And we just kind of perpetuate this watered down, diluted, diffused semantics of this term. Or would you get somebody going over saying, well, back when I was at Google, this is how we did it. Like that means something. Like, cool, congratulations. You were able to invert a binary tree on a whiteboard and you worked at Google. Like, just don't have to post those windows. Don't even try. So I'm not trying to knock that. But when you go from Google to not Google, you're not Google anymore. And the whole landscape shifts. And so what we get is we get a lowest common denominator of every single one of these patterns, even though every single implementation is going to be different. So what is microservices? Well, it's taking an application, breaking into 100 tiny pieces, and suddenly it becomes scalable and deployable and end. Okay. We get this flat taxonomy, but where we're defining these things by their lowest common denominator, by their topology, by whatever. And then you go to your team and say, hey, we're building microservices. And they're like, okay, cool. And fundamentally, though, these patterns aren't architecture. They're a side effect of architecture. And I'm realizing it's been going kind of slow. All right. Well, I'll pick it up. I don't want anybody to, all right. Just enjoying being around people. So the only time I presented this has been to the light on my webcam. And so, I got the webcam there. Hello, remote people. If you're still watching, I don't know. But we'll get to the meat of this, and I'll take you through it. But ultimately, the tailor-made model, it's not about the patterns, it's about the decisions. Because the way we look at it, in any project, there exist set of decisions. And within that set, there exists a set of decisions that are architecturally significant, that materially impact the capabilities of the system and the extent of those capabilities. And when we look at these patterns, as diverse as they are in terms of implementation, topology, capabilities, each of these is the result of just a handful of architecturally significant decisions. These are decisions around component granularity, around topology, around how we define module boundaries, how we do data persistence and isolation, constraints around code reuse, how asynchronous communication takes place. And so these patterns are defined by different combinations of these and some other what are called architectural constraints. We're constraining the degrees of freedom. There's much more. But the thing is, the capabilities don't come from the patterns. They come from the decisions that define the pattern, specifically the architecturally significant decisions, and even more specifically, the architecturally significant decisions constrain the degrees of freedom in terms of how you build the software. And so nothing magical happens when you take an application and break it into 100 tiny pieces. But when you put together, when you bring together all of the decisions that define architectures, all of the constraints on the degrees of freedom, these capabilities start to emerge. And this isn't a new idea. I mentioned Roy Fielding and REST. I've read his dissertation several times. And the thing is, it's not about REST. Like everybody who references that, they're like, oh yeah, that's the source. Chapter 5, he talks about REST. But like I mentioned before, he talked about how to take a better approach to designing network-based architectures. And he was building on ideas. He was building on a broad set of ideas that already existed. Right? This wasn't a new idea, this idea of architectural constraints. I mean, Fred Brooks was talking about this in the 1970s. In 1992, Perry and Woods wrote a book called Foundations for the Study of Software Architecture. And they talked a lot about, well, if it's a free-for-all, you're going to get a mess. When you constrain the degrees of freedom in different ways in how the system is implemented, you get different capabilities. In 1996, Software Architecture Perspective on an Emerging Discipline. 2000, Roy Fielding's dissertation. 2016, Software Architecture Constraint Reuse by Composition. And over again, we've seen in theory and in practice that we can think about architecture as a composition of these decisions. And when we identify and codify these decisions, they become little atomic building blocks for building an architecture precisely and deterministically. Now, what's really interesting, and I'll talk about this in a minute, is in 1992, Perry and Woods, in their book, said that in theory, not only to have this idea of a constraint as that atomic architecturally significant decision, and we know that it's going to induce some capabilities, it's going to weaken other capabilities in the overall system. We should be able to actually weight these. That when I add that decision, it's going to be +2 agility, -2 cost, right? Or whatever metrics we're looking at, whatever that decision affects. And then in 2000, Fielding talked about that in his paper. And he said, Perry and Woods and others, they've said, yeah, it'd be kind of cool if we could score these, if we could weight these. But nobody ever has actually sat down and came up with a scoring system for measuring architecture and measuring these different capabilities. And then in 2020, Mark Richards and Neil Ford published Fundamentals of Software Architecture, where they did exactly that. And it's like, okay, we've got a definite definition of the pattern and the characteristic scores with a broad enough sample to be statistically relevant and meaningful. And now we get design time feedback. And then, so that's part of that tailor-made model. Part of it is connecting each decision with not only what's it going to do for these capabilities and how do we connect these capabilities to the business requirements, but going the other way as well. What's this going to require for the organization? How do we actually look at this in a more holistic way? And basically, what came out of all of this, I found out, is if you change the way you look at things, the things that you look at change. So part of what came out of this is an architectural style. This term architectural style, which is a name coordinated set of constraints. So let's actually look at this now. Let's see what this looks like and how this model enables evolution and how we can connect these capabilities to the metrics, to the business, to the teams, we can basically connect everything across the board. So if we start with a project, right? Big no constraints, it's a free flow. You want a God class, 30,000 line God class, 5. You want to mix and match randomly OO and functional paradigms? You want to put everything in one giant void main, your entire application, do it. It's a free-for-all. You want a half REST API, half RPC API, half SOAP API, half GraphQL API, and just a little bit of everything, right? the kitchen sink strategy, have fun. We get the big ball of bug. Has one constraint. It's a monolith. Not necessarily, because there are also distributed big balls of bug, which we've talked about already. And right, that's it. Defined by one constraint. But we can add another constraint. We can say, you know what? We want a separation of concern. And that's going to improve total cost of ownership, testability. And maybe we add a shared database. Okay, cool. And again, it's going to start moving the needles on some of these capabilities. They're still really weakened, but they're basically bottomed out as they are. So, some of these are going to get moved up, but it's going to be negligible. And some of these are going to be weakened, but they're already terrible. And if we add a little more modularity to the system, one more constraint, one more atomic architectural building block, we get a pattern, right? We get the layered monolith pattern. I consider it not necessarily a pattern, but an abstract style, because it's an architectural style in that it's a name coordinated set of constraints. But this is not the only thing. It's not the start and the end, the alpha and the omega of what a layered monolith is. It's just the core, the essence. Take those away, it's not that architecture anymore. And and we know this. It's kind of the de facto architecture. From time to time, one of the things I'll talk to a client is, what kind of architecture do you have? I don't really have an architecture. I'm like, okay, cool. It's a layered monolith then. Got it. And we know about this. Basically, the idea is that we're separating these things in terms of technical partition. You get good, clear roles and responsibility models and things like that. We get some degree of abstraction and isolation. At the same time, we also know if I make a change that involves a database change, then I'm going to have to update the persistence layer. I have to update business logic and the services and the presentation and the UI and all of these things. It's going to cascade all the way across. And then once we tested this change, the whole thing. That's one of the things that's one of the reasons we don't like this style. But the thing is, it's the starting point, it's not the destination, it's not the finish line. And so for a lot of projects, this might actually make sense. It does make it. There's a reason that it's basically the de facto architecture out there. It's easy, it's well understood, high speed to market, all of these things. But suppose that either this is where this is a greenfield and we know that this is not going to cut it for the project. We've talked to the business, we understand what they need. This isn't going to cut it. Or suppose it's an existing application, this is where we started, but it's not doing it anymore. So we now actually look at this architecture through the lens of the customer. Is it delivering? Are we in alignment? What have we learned by putting this software out there? What are their hypotheses? Let's just assume, for example, for the sake of argument, this is where we are right now. And we put this to market, we learned more things about the features, but we learned more things about the architecture itself. Maybe performance and scale are becoming a bottleneck. Maybe occasional downtime is causing complaints. Maybe the business wants to be able to get new features to market faster. And of course, the business is trading these benefits for a little bit of cost and complexity. So how do we get there? Remember, because if you look at this is what you're going to get. If you apply pattern thinking, this is what you're going to get from the monolithic architecture. This is it. A lot of ones, a couple fives, and a two and a two. But all of these capabilities are a direct result of these constraints, these architecturally significant decisions. So we could add, for example, the client server constraint. And it's gonna give us some benefits, some trade-offs. And then at some point we have to apply some kind of API strategy. So maybe we call it a level 1 on the richness and maturity model. Okay, we're level 2, we get a little fancier. Or we say, screw it, we're gonna use GraphQL. Or we say, we're just gonna build an RPC, we're gonna use gRPC, or just a regular RPC over HTTP kind of endpoint. Like, all of these give us different results. But we're still not getting them. And if we apply another constraint in terms of, basically we change that monolithic component into these sort of coarse-grained kind of components, we start to take it apart and we cut along the seams. We have coarse component granularity, we've got layered system, and we don't want to be in a situation where we have to coordinate deployments. So when we add that independent deployability constraint, we get the distributed end-tier kind of style. Right? And essentially, we're just cutting it and decomposing the system along the seams. Now, most people don't tend to do this because it's an old architecture. Microservices have been the new hotness long enough to be the new hotness. But it makes sense. It's one way to cross. It's one way to evolve the system when you cross that distributed systems trade-off line. And again, it's a trade-off line because we get a new set of complexities. Like this is Peter Deutsch's 7 fallacies of distributed computing, and we can't just pretend this is that those things don't exist. That the other one that gets challenging at this point is not just the fallacies, but we have to think about how we're going to enable independent deployability. So it's an abstract style, which means we can and probably should extend it. We can scale IO, we can remove bottlenecks, we could use that fantastic replication that MariaDB gives us, and the modularity of the storage engines to to do cool things. I've done cool things, by the way. All right. The pluggable storage engines is it's true. Because I was actually probably several years ago, and we were reaching this version on our primary. We're hitting our on the primary, and there were reasons that changing the code was going to be hard. So we changed the right heavy tables on the primary. They were like mainly right only. We used the black hole storage engine. And so if you haven't, the black hole storage engine is basically your table is dev null. Insert, succeeded. Use it away. But it replicates that transaction. So I had a bunch of servers that were it's a good idea sometimes.
Just, as a quick plug, MariaDB has this thing called max scale. It's a project. Do read write traffic splitting exactly. Right. Sorry, I jumped ahead. I'll be quiet now.
No. I appreciate it. You made my job easy for me. Yeah, I used to have a talk. Nobody cared. Called Scaling MySQL with Galera and Max Scale. Is Galera still around?
Yeah. Oh,
That was super cool. Anyway. But yeah, we can do this. We start changing. We can improve mean time to repair, elasticity, scalability, things like that by breaking some of these services apart where it makes sense selectively, right? We've got multi-grain services now. Maybe we can add some async components where that makes sense. Like, there's no end to how you can kind of evolve these things. But assuming we're here now, in terms of and it wasn't a huge lift to get from where we were to here. So we can achieve this evolvable piece. I just realized.
Think about it, kind of like read write splitting. It's like a code you run. You have some control, right? Some amount of control, but it's stateless. Database server, like block from the vendor or block from the open source technology. Levers you can't control, right? So you can say, read write splitting across different nodes. That suddenly you just gain 50% scalability, like about 2 times the system for different workload profiles that you can throw different hardware at. But that's black box. As a developer, right? You just kind of like write the incantation, and then what is the silver man, right? Yes.
Oh no, you got it. But I'm thinking one different direction before we wrap up.
Yeah.
Because, like I said, decomposing that monolith wasn't super hard, but it's not the direction we necessarily want to go. Most people, when we talk about decomposing monolith, we're talking about microservices. And to quote, and I don't know why when I was writing this talk, this line from a song came in my head. Yo, you know where it ends, yo, it usually begins on where you start. This is why I don't do music at all. If we're starting here, it's gonna be challenging. Or maybe we're starting here, maybe we're not. Maybe we're designing up front, we have a hypothesis, but we've got a different set of priorities. Maybe scalability, performance, and elasticity, they're not that important yet. They might be in the future, but they're not that important yet. Our top priority is we want to focus on more agility, faster features to market, lower defect escape rate, more flexible integration, interoperability, with more stable abstraction, something that's not maybe as quite as complex as N tier. But as before, the business doesn't mind sacrificing cost and complexity. So we know that a different set of outcomes will get us, a different set of constraints will get us a different set of outcomes. So what if instead of slicing this monolith horizontally, we slice it, right? And we don't at this point we can't partition by technical boundaries because they're going to bleed across everywhere. So we need to find a new way to find module boundaries because we've got to find those vertical boundaries. So we domain partition this architecture. And again, you add these constraints, we have a new architectural style, right? And we still have some problems. Like, remove this problem, right? We have cascading changes. What's cool about this domain partition module is each domain module is isolated. It's completely standalone. So I can make a change here, and the blast radius is constrained. I can make a change here. I can make a change here. But the problem is, if those changes, you still are huntling, and that could still be a gotcha. And so we add one more constraint in here. We say that each module owns its own little slice of the database. We're going to partition the database. And when you do this, you get the modular model, which is, it gives you a lot of architectural flexibility for the future. Now, inside of here, you still have these, you're defining it by these constraints. And when you're designing a system, when you think about granularity, it's easy with a layered system. It's a little harder with this. You've got to kind of figure some of these things out as you go. But we want a derived instance of the style. We don't want to directly instantiate an abstract style. So again, we can keep going. We can add client server and an RPC API. And what if we broke apart this monolith though? The same way we broke apart the layered monolith at the seams. And so now we're back into a territory of distributed systems. We need independent deployability to actually achieve this agility. And then we have a choice, right? We can keep this partition shared database, or we can just share it and keep it a little simple. And formally, the definition of the pattern, we take that constraint out, and we have the service-based architectural style. And it's actually it's a good first place to cross the distributed payoff line when you think you're going to eventually cross the microservices payoff line, right? We still have manageable transactions. It does have some requirements from the organization and the teams and the environments, but it's not totally out of reach. And so we start to get this, and then we can kind of further we're getting reasonable trade-offs, and we can further refine this because we've got some architectural flexibility, right? We can start to split up the database. This will work if your data domains are isolated enough, not always the case. We can continue to split these up. We can go finer grained in this whole thing and start bringing in more operational automation, bringing that independent deployability, and everything the microservices, we can step by step move that direction. We can evolve. And we can evolve based on what we're learning from the organization, what we're learning from running the software. There's a lot of benefits, right? But it requires a lot of the organization that actually has to build and run these things. It's not easy. It just keeps going. It is not easy. And that's one of the reasons I like that model is it puts that in context of every architecture decision. Okay. So the whole idea of agile architecture, let's put all this together, and then we go home or Miller time or whatever. Because one of the key things is the concept of agility and software delivery. It's dependent on frequent communication with the stakeholders. And this is still true of the architecture. It's not like I talked to the business once or 5 times or 10 times. I know what we're trying to build. I think I know what the strategy is. So I'm going to design the architecture to support that. It's an ongoing and continuous process. And we talked about a lot of these capabilities. Now, these kind of, we start with capabilities. We form a hypothesis based on the requirements. We rank and score them with a goal of enough for now. And then we induce the capabilities through constraints. And it builds on, and so all of this stuff builds on 25 years of work, actually, more than 25 years of work, but 35? Actually weighting these things. But the thing is, like I said, when you change the way you look at things, the things you look at change, and evolving architectures, it's just not that daunting anymore when I look at it and when I work with my clients and when I do what I do. But one of the things you got to realize, not all constraints are created equal, right? This going from that layered monolith to your distributed interior style architecture, it's not a huge leap because very few of these constraints really need significant organizational changes or culture changes or skill changes, right? Decomposing across the natural boundaries is fairly straightforward, but going from the layered monolith to microservices is insanely hard. So many of these constraints completely transform how the entire organization has to think about software development, software delivery. But one of the biggest things that comes out of this is changing that module partitioning is hard. So at a very high level, a new taxonomy to think about the pattern is not just distributor monolith, because as you can see, if you're splitting along the seams, decomposing a monolith is not hard. So arguably, the first one, the domain module definitions, is one of the hardest constraints to change. And then when you look at this, you can have monolithic or distributed services. Crossing that line is not that difficult. And we go through. Yeah.
I don't know if you're familiar with Oliver Storage at the Spring Team Spring Module, but he was just posting that actually does that modular monolith kind of architecture building. You can say just actually did both use April 24 software design report. Like really interesting to take on the modular monolith.
Yeah. Well, and I
making it, utilities to help you make it.
because I don't think I've actually seen good tooling around that. Like I just roll my own. Like one of the first things I'll do in an organization, if that's the direction we're going, is I'll set up the reference implementation. Here it is, and here's what we're going to do. We're going to put each module in its own package. We're going to scope everything internal, because one of the things that's interesting is one of the reasons we want to go to microservices is it forces a certain level of architecture. Right? It forces you, like in a monolith shared code base. I can go in quietly and change that to public because I just need to poke into that one thing. Nobody will know. But you can't do that, right? In a poly repo microservice environment, you can't just do things like that. Although we end up doing it anyway with shared libraries and shared services and all the rest of it. But whatever. But we scope everything to internal. We use architecture governance. Like we don't have to build a complex distributed system to get architectural governance for free, right? And we can connect. So not only can we figure out which of those constraints are easier or harder to change, we can connect them to the organization, to the environment, to the team constraints, what we need out of these things. And we can take this approach to incremental maturity, because the two things come up. One is, if you want to do sudden maturity, basically I'm telling every single developer in the organization that everything you know is wrong. And what you thought you were good at, well, let me show you a whole bunch of other skills that you're going to need that you're not good at yet. How's your IAC? How's your cloud formation? How's your TDD? Senior developer. TDD. Right, all these new skills. And yeah, we're going to copy paste that code. But it's the same for all these microservices. Yeah, and we want to decouple them. But that violates dry. Does it? Either way, we're making that trade-off. You got to do dry. You got to do single responsibility principle. These are a religion, and you can't tell me otherwise. Architect. But the thing is, and you're making all these changes for zero actual immediate benefit. They will pay off maybe someday. But when you're taking this incremental approach, it's like, hey, we're getting a little bit of friction, it goes away. We're getting a little bit of friction, it goes away. We're getting a little bit of friction, it goes away. And maybe, ideally, right, your organization isn't uniform, and now you need microservices, but you did the right thing at the right time, and you didn't blow all your runway building infrastructure for microservices when you never brought anything to market. Where are the payoff lines? Basically, I kind of wrap up with this. the question really is what's enough? And I was in the middle of nowhere in Wyoming. I'd been driving for 2 hours and I hadn't seen a single car. And in 2 more hours was the next town where I could get gas. And it was a town called Muddy Gap. It's actually what it's called. Population of Muddy Gap is 3. I kid you not. Population of 3. But in the middle of that 4-hour drive, I drove into a modern and pretty well established looking town. And I've been driving for probably, for a few minutes before I realized that something just wasn't right. And it hit me. There's nobody here. There's not a soul. This is a ghost town. It was in the 1970s a company town for a uranium mine, and then the market kind of fell out of the bottom of the market. The bottom kind of fell out of the market for uranium somewhere around 3 Mile Island or Chernobyl or the end of the Cold War. I don't know. Somewhere around there, like we just didn't need nearly as much uranium, and the mine shut down, and everybody left. It's a ghost town. And then I saw this building and a bunch of these little airblade flags. They were flying. And the only sign of life. And I wandered in, and it was whatever. And it's 11 o'clock in the morning, and a slobbering drunk man staggers towards me, and thanks for coming to my studio. I guess like that's Byron Seeley, the Mad Potter. I guess there's not a lot to do in Jeffrey City, Wyoming, when you're the only person there. And there's only so many pots you can make before you go crazy and you pass that line somewhere. Super interesting guy. I talked to him and I had to ask. They said, "What here?" He says, "What do you mean?" I said, "Well, I've been out there for 2 hours. I haven't seen anybody. Do you get a lot of business?" And you could tell like he's been asked this question a lot. And so even in his current state, when you could set fire to his breath, he says, "What's a lot?" I don't know. Neither do I. I know what enough is. I get enough. And it's just kind of, I don't know, it kind of stuck with me though. Yeah. I don't know what a lot is. I know what enough is. And we can measure that. And I think that's the key thing. Architecture is as much about monitoring as it is design. For a while, I was a DBA. I was a DBA for a couple of years. Don't hold that against me. Well, since you're working for MariaDB, who are actually doing good things with when they fork MySQL, you know what DBA stands for, right? Stands for don't bother asking. I was a DBA for a while, but like, I helped design these tables. Great. Job's done. I can sit and drink coffee all day. No, I'm checking, running MySQL or the MySQL dump slow or whatever it was. Or I'm looking at metrics. I'm looking at all of it, wait times, latching, IO, and it's the same thing with architecture, right? It should, basically building according to the constraints and monitoring this and monitoring adherence and governance and alignment with the business and the metrics. It's a near constant activity, not some after the fact verification that we tend to see, right? And I mean, I could talk a lot about metrics and different things and ways to connect these and ways to monitor these things. But ultimately, when we're looking at the architecture, we're evolving the architecture, we're answering this question every time we change something. What is the business value? And, I talked a little bit about architectural decay and things like that, but we were like way out of time. 15-ish minutes over, that's not too bad. Because architecture does seem to rot over time. But we don't need a distributed architecture to give us architectural governance. There's lots of ways that we could. I use Sonograph. I use various architecture unit testing kind of frameworks. That's a quality gate in my build pipeline. Because if I have a modular monolith and eventually think I want to get to microservices, then I can't let those boundaries dissolve. So I've actually got to put architecture governance in place. And that's part of what we do. But all of this is just one dimension of the whole tailor-made model and approach and things like that. And just as the world changes, because it is April 17th at 8:17 p.m., this stuff just feels more and more important to me. I was chatting with somebody on this topic, a guy named Daryl Reels, and he said this, and it really kind of stuck with me. I believe that the engineering effort is going to undergo orders of magnitude automation if we only build crappy software faster with less human effort in the building and testing. What have we accomplished? Architecture may be one of the last remaining human-centric activities that we employ, and we had better do a good job of it. Otherwise, we'll just have a bigger mess on our hands. And I absolutely believe this because it is cool. It is enormously cool that a language model can write code that compiles a lot of the time. Sometimes it just like makes up methods. It's done that to me a bunch of times, and then I go back to it. I say, I think that's I'll try to make it work for 20 minutes, and then I'll go back. I don't think that's a real method. My apologies, you're correct. That's not a real method. But anyway, I see somebody coming in to kick us out. So,
Might be.
which is good timing. So I will I will leave you with this. I have a 3-day deep dive into the model, the processes, the tools, all the things. If you are interested in architecture, if you're interested in going deeper into this this entire space, I've got a training happening in Reston. I was hoping to be here in December because I did one in San Jose in March, but then right before the event, I went down with COVID, and I thought, but I really want to go to California. I really want to talk about this, but I figured it would be a really crappy thing to do to show up and then be like, oh, y'all have COVID now, and it's Christmas, so go cancel all your plans with your family, and or expose grandma. Um, and I know we're a few minutes over, so I will I will spare you the 60-second video. It's online if you want to see it, but we are out of time, and with that,
We'll share the slides with everyone while the recording.
cool. Right on. And with that, I will say thank you.
Thank you. I feel like this stuff is super important, and I think I've been listening to say there's so many times where vendors come in here and they fix the tools and stuff like that, and it's one of the few instances where I've seen not necessarily a prescription, but an opinion on how you evolve things over time. I think that is just key. So I really appreciate being here, Michael, and having that opinion and having a lived experience to kind of talk about how you move in your architecture. So many people think about, well, you measure it, you forward, and then you're on microservices, and it's like it's like a strain. Like you illuminated all steps to me, and what reasons you might have to do some of those order 18 or 8 steps.
Yeah.
That's gigantic. Gigantic. So I really appreciate it. And I feel like the cloud has kind of made this especially so many people wanting to make a cloud platform or a cloud product. Wanting to start with microservices because of course my application is going to be multi-region. Of course I'm going to be operating multiple buildings. Right? So of course we need to start with microservices, and we're going to encode all that coding and we're going to have you mentioned your build pipeline, your
Yeah, that's what we do. So, so the first thing that you're having a chance to governance is building in your CICD. It's sort of the those that do that. And it becomes, and I think it becomes more relevant in those intermediary stages, like if you're building an algorithm, for example. There are tools like that in the Java ecosystem. There's each unit or each unit. I've heard of both ways. But it allows you to define particular rules. It uses kind of a fluent API kind of approach that like, hey, these things can't talk to these things, or this layer can't see past that layer. It's really easy to define these rules. Photograph has a program called Photograph has a program called Photograph Protect, and it has similar kinds of capabilities. We're going to do it. Yeah, we're just in the .NET ecosystem, they use Sungraphs while they were in a lot of ecosystems in the .NET ecosystem. There's two that are kind of variations in the same way you've got JUnit and like NUnit or Glutamate and Hibernate. There's Arch Test and Arch Unit Net. Um, I don't quote me that both of those projects are still out there, but they're still out there. Um, but it also makes it really easier when you're thinking in terms of constraints, your architectural constraints. Um it's just it's one atomic constraint, one atomic decision that constrains and degrees of freedom. How do we measure that? First, if we measure we're doing record services right, there's so much, but you measure one detail. So when you're thinking about architectural constraints, you don't over describe, you don't over describe. You have to think about how you're going to maneuver or who's going to be maintenance on each one of those constraints and how you're going to support that constraint. Well, it's not just that moving tower hood, the main partitioning, figure out it's like, or we're doing this particular thing. As an architect, I still spend a lot of time writing code because part of my job is to package pain for the organization, whether that's a spike, a POC, reference implementation, tooling, so I'm thinking I'm going to support these things, I'm going to verify and validate these things. And what metrics, business metrics and what customer metrics am I going to monitor for the fix? And so it's a broader look at all of those things. Right. Quick Zoom rooms, if you want to do something like that, there is one hang out. And my banana or but if you want to do that, you can just there's a bar in a form goes in the so it's a little 11%, my banana is and what happens with that. The 3 minutes of the fact you know, my thing. Yeah. And you want to see something quick and interesting? You got seconds while we're if this is everything I know, then something like the other side and the super side. It's always been kind of room because I find for me, I think there's the Facebook mic, there's TV mic, and there's addition. One of the things to me, I'm saying, anyway, everything I did, I take myself the practice because it was always very and a from the software engineer, software accident. Really my from software architect or my software architecture from musician, it just like it had to be an exclusive one. And then finally, last couple of years, I figured out that right, I'm a whole bunch of these things. Am I a lifter? Am I a magician? Am I a speaker? Architect, a food monkey? Am I a fidget skin? Am I a skydiver? And in the words of Bill, my audio, I'm none of those things. All of those things. That's something that I'm looking at. Like that? Yes, that is